Hello, everyone. Welcome back. It's me again. Decided to keep up this nice image. So, in our last lesson together, we introduced rigid transformations and we started looking at translations, which you hopefully followed up with in class and got some information and got a chance to ask questions and for clarification. And what we're going to do in this lesson and what you guys are doing over this weekend in preparation for our next live session is we are going to continue working with, that is embarrassing, a look at using a coordinate grid and using some of our background knowledge of graphing points and graphing shapes and what we learned about rigid transformations in our last lesson together, right? Rigid means it maintains its shape and size, and transformations are translations, reflections, and rotations. So we're going to develop and apply, right? So I'm not just going to hand them to you. We're going to discover them. We're going to really investigate to develop these rules. And we're going to apply these rules about common reflections. So there's not going to be rules about every possible reflection that could happen, but there are going to be some critical rules that we're going to go through. And I'm going to talk a lot about how if you're someone that memorizes and you're a big note card user, go for it. I'm not a memorizer. So I'm going to talk a lot about how you can develop these rules and create a general understanding of them. So hopefully you have your notebooks out and maybe you've printed out this presentation or you're using it to help guide your note taking. So first, I'm going to start right here. And so I've got, you know what I'm going to do before I go too far? I'm going to make a few copies of this page so that if I'm taking up too much room, that I'll be okay. I'll be good to go. Amazing. Okay. So I've got this triangle ABC. And remember pre-image and image? This is my pre-image. There's my initial pre-image. I'm going to do some transformations to it. So I'm going to start off, and this first one tells me that I am going to reflect it. Let's see if I can make it a little bigger. There you go. I'm going to reflect it across the x-axis. Here's the x-axis, so I'm going to reflect it across this axis right here. Ooh, that is horrific. A little better. So a big thing that I like to do is just count the distance. If you think about a reflection, if I were to fold, let's say this is a piece of paper, and I literally were to, you can't see what I'm doing, but I literally were to take it and fold it, I want to know where each one of these points would end up. Where would this B end up, right? It would fold up, and it would end up being right here. You can think, oh, it's 1, 2, 3 away, so it's 1, 2, 3 away. Think about if I get really close to the camera versus I get farther away, what am I like on the other side of the camera, right? If you're looking in a mirror, the closer you get, the closer it is. It's the same. It's equidistant. There's a good word from that line. That line is actually, this is an amazing connection I'm about to make. If I connect B and B prime, that line that we're reflecting over is actually the perpendicular bisector of that segment. How awesome. Okay, cool, right? Isn't that cool? I bet you're all sitting there and you're like, wow, that is so cool. So over here, 1, 2, 3, 1, 2, 3. Here's C prime. And then this is farther away. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is going to be A prime. Man, my triangle's looking a little not like a triangle. So, let's actually, I never wrote what A, B, and C are. A is -2, 1, 2, 3, 4, 5, 6, 7. -2, 7. What's B? 1, 2, 3, 4, 1, 2, 3. -4, 3. And C is 0, 3. So when I just did that reflection across the x-axis, this is negative, I should do A first. -2, -7. Think of what just changed there. What about B prime? That is going to be -4, -3. Huh. Are you noticing a pattern maybe? 0, 3, 0, -3. So maybe you noticed something. We started with xy, started with -2, 7. What happened? What happened to our x's in all three of these instances? Because it was a rigid transformation. This is function notation. Well, x didn't change. What happened to our y value? We subtracted 14. Oh, no, wait, that didn't happen here. Or here. Oh, I messed up. This is a -3. What happened to all of them? They all became the opposite sign. -y. And keep in mind that that negative just means opposite. So x stays the same and y becomes opposite. So when I reflect across the x-axis, x stays the same and y becomes the opposite. Very interesting. Let's look at the y-axis. I'm going to do this on the same grid. Let's do a new color. Here's my y-axis. I'm going to go back to the original. I'm going to use pink. So distance. Whoa. C is right here. Well, it's not going to move. That's also going to be C prime. I'm just going to call it C prime because I'm going back to the original again. A, 1, 2, 1, 2. This is A prime. 1, 2, 3, 4, 1, 2, 3, 4. This is B prime. If I do something and it doesn't look like it's the same triangle, wow. I made a mistake, right? So this base should still be 4. Yeah. Okay, so let's see. A prime is 2, 7. And remember, we're going to compare it with our pre-image. 2, 7. What's B prime? 1, 2, 3, 4. 1, 2, 3. +4, 3. Whoa, sorry, guys. The computer's all wonky. And what about C prime? That one didn't move, right? 0, 3. So what happened here? I started with xy. Remember, I should be able to look at any of these points. -2, 7. And what happened? -2 became +2, and 7 stayed 7. -4 became +4, and 3 stayed 3. 0 stayed 0, and 3 stayed 3. Well, now my x value became opposite. So it's -x, y. So do you see how you can sketch yourself a little graph and come up with these, right? Or come up with a way to remember it. Okay, when I reflect over the x-axis, my y becomes negative. When I reflect over the y-axis, my x becomes negative. There, we just developed 2 rules. What's our next one that we should come up with? Oh, darn, that's unfortunate, isn't it? Oh, darn, that's even more unfortunate. Okay, we're going to reflect over the line y equals x. And you know what? I'm going to do that on this page. Y equals x. So the line y equals x. Y equals x. That's like y equals mx plus b. But my y-intercept would be 0, 0. My slope would be 1. So it's going to be this diagonal line. I'm going to pull out my line tool so I don't embarrass myself right now. Even though I still might. Nope, that was pretty good. So there's the line y equals x. I'm even going to label it for you guys. So I'm reflecting across that. It's a little hard because we can't really count on a diagonal. But it's okay. I might need a refresher on what is A prime, B prime. What is A, B, and C? So B was -4, 3. C was 0, 3. And this was -2, 7? Yeah. Man, this is, I'm having some tech issues. -2, 7, yeah. Okay, so I'm going to attempt to count on a diagonal. Let's see, I go 1 and a half. 1 and a half. Here's C prime. It's a little tricky, right? Because you got to think, if I were to connect these, this should be the perpendicular bisector of that segment. Crazy. Sometimes I will see students go, you go down and over and down, and over and down. It's like you got to think about where would that end up, which is a little bit hard. You got to turn your head. I like to count on diagonal, even though you can't actually. 1, 2, 3, 4 and a half. 1 half. 1, 2, 3, 4. There you go. There's A prime. Let's see this one. 1, 2, 3.5. 1/2. 1, 2, 3. I'm counting, and that's like the slope right there. So this is B prime. I tried to make it look better, right? So it's like you might need to like turn your computer or turn your head and see that like if I were to connect A prime and A, like I'm going to do it and then I'm going to delete it in a moment. But if I were to connect these two, this is the perpendicular bisector of that, right? So this is halfway between them and creates that 90-degree angle. So let's see, what are our coordinate points? A prime is 1, 2, 3, 4, 5, 6, 7, -2. Oh, no, no. No, no. I did this one, and I did this one. 7, -2. B prime, let's do C. 1, 2, 3, 0. Huh, do you notice anything? 3, 1, 2, 3, 3, -4. So what happened? We obviously started with x, y, but -2, 7, 7, -2. -4, 3, 3, -4. 0, 3, 3, 0. Whoa, your x and your y switch. This is actually how you're going to start stuff next year in Algebra 2. You know, I'm a year ahead, but this is inverse, right? This is like the inverse. It's a reflection of the line y equals x. Pretty neat, though, right? So we've now got these rules. X-axis, x stays the same, y becomes opposite. X, y. X becomes opposite, y stays the same. So I've reflected over the x-axis, the y-axis, and the line y equals x. These are the three most important ones. This one is fairly important, the next one that we're going to talk about. The other two are actually not going to have rules. So the line y equals -x. I would like to still be able to write this. So the line y equals -x, so that's going to be a decreasing line. So it still has this point at 0, 0, but then it's going to have points. I'm going to go up one, left one, up one, left one, up one, left one. So it's going to be that diagonal line, the opposite one. So let's see if I can get, that's not a different color. Here we go. Right, so this is the line, and I'll go ahead and label this one as well. Y equals -x. So now I want to reflect it across this line. This is going to make it a little bit confusing because it's going to be overlapping. So this B is half away. So I'm going to go right here. It's going to be B prime. This is going to be weird because it's overlapping, but it's okay. 1, 2.5, 1/2, 1, 2. A prime. 1.5, 1/2, 1. This is going to be C prime. So let's see. Overlapping. But if I were to fold it, think about what would map. It's the same thing, right? This would end up over here. These two would end up on top of each other, and these two. So what are the coordinates of C prime? -3, 0. Right, so on this one, -3, 0. And remember, you're going from this up here. So think 0, 3 to -3, 0. What's this next one? B prime, I end up at -1, -2, -3, 4. -3, 4. -3, 4. So think about, I went from -4, 3 to -3, 4. And then finally, -2, 7. Where does A end up? -1, 2, 3, 4, 5, 6. -7, +2. So what exactly happened there? I started with x, y, -2, 7, -7, 2. So my y value became my x value and became opposite. And then my x value became my y value and became opposite. So they like switched and negated, right? So it was similar to this. Let's see if that works. My x became my y and became opposite. My y became my x and became opposite. My x became my y and I guess became opposite. It's a 0. And my y became my x and became opposite. So they switched and they both became negative, right? We now have the 4 rules of reflections. These are the 4. And notice that we can come up with them. Like I just showed, you can come up with that. You never, ever have to have these memorized. You can always go over in like the little corner and sketch yourself a graph and say, well, what if I had the point 2, 2? That's maybe not a good one. 2, 2. And I wanted to reflect it across the x-axis. Where does it go? And you can develop the rule. I often do that. We'll summarize in a moment. So I do want to look at those last 2. I think there's 2, right? Where you're reflecting over the line y equals 4 and x equals -3. And there is no rule. There isn't. We could come up with one, but it's a combination of a bunch of transformations, and we're not going to worry about it. So I just want to look at how you would do it. So the line y equals 4. The line y equals 4. So let's find on your y-axis 4. 1, 2, 3, 4. Here's the line. Y equals 4. So again, remember you're counting the distance. So if this is B, count it away. 1, 2. And you're going perpendicularly. B prime. 1, 2, 3. 1, 2, 3. This is A prime. This is 1 away. So 1 on the other side. C prime. This is gonna be weird. It's gonna overlap. But it's the same figure. It's reflected though. It's a rigid transformation. And finally, what was that last one? Oh, I just moved myself. I forgot what the last one was. X equals -3. X equals -3. So let's go ahead and find 1, 2, 3. X equals, this is the line x equals -3. And again, you'll count the distance. And we're not coming up with a rule for these. 1 away, 1 away. This will be B prime. 1, 2, 3. 1, 2, 3. C prime. 1, 1. A prime. And this would be the result. This would be the image of pre-image ABC reflected over the line x equals -3. Cool? Amazing. So, I did a lot of this. I want to summarize it. And I thought I would lay it out like this because I think this is a great place for you guys to summarize it. If I were you, I would take a piece of paper, fold it into 4, or create 4 spaces, or however you're doing it, and kind of summarize what you're doing. So this is going to be the coordinate notations for reflections. So I'm going to have x-axis. I'm going to have y-axis in no particular order. The line y equals x, and the line y equals -x. So the x-axis, I'm going to sketch myself a little graph. This line right here is the x-axis, right? So the coordinate notation for this is xy becomes, x stays the same, y becomes opposite, okay? The y-axis, and if you need to write yourself more notes, this is a great place to do that. I'm going to put a dotted line here. Here's my y-axis. xy becomes, think about when you reflect over that, your x value is going to change, but your height isn't, your y is not. It's bothersome that my computer is doing this. Becomes, x is going to become the opposite and y will stay the same. And so I keep saying opposite because I don't want, if it was positive, it becomes negative, negative becomes positive. The line y equals x is this diagonal line. And if I had xy to reflect over that, I've got yx. And finally, y equals -x is this decreasing line. This is crazy. These two are perpendicular. Their slopes are opposite reciprocals. So I've got x, y, and then not only do x and y switch, but they both become negative. Okay, so these are really the 4 rules that we want to know, whether you're developing them as you go or you're somebody that's memorizing them. These are the 4 rules we're going to be working with and we're going to be applying. So that's what we're going to do right now is we're going to do some application of this. I'm going to go ahead and move myself over here, but let's apply what we learned. We got this, guys. So I'm going to start off with these few, and this would be a great place that if you're ready to pause and try it on your own, go for it. And then come back and watch. So find the coordinates of the vertices of each figure after the given transformation. So reflection across the x-axis. At the beginning, if you need to use your notes, go for it, but challenge yourself and see if you can do it without your notes, right? That's what you would eventually, we want to be able to do, is we want it to be second nature. So what I like to do is think through the rules. X, Y. If I'm reflecting across the x-axis and something flips down, the height is going to change, but like the way it is, like where it is on the x-axis won't. So my height will change. So it's going to be x negative y. And I'll just go ahead and write that. So our prime would be x negative y. Sorry, my computer, my slate, my computer, I don't know. There we go. J prime, x stays the same, y becomes opposite. X stays the same, y becomes opposite. And if you would like to graph these for yourself, think -2, 2, -2, -2. Oh, that's we're going opposite ways from the x-axis. What about here? Reflecting over the y-axis. We had x, y, and it's going to become, reflecting over the y-axis, here's the y-axis, if you're moving from one side to the other, your height doesn't change, but your direction will, right? So y will stay the same and x will become opposite. So x becomes opposite, it will be -1, -3, -1, 2, -4, 1. Let's say I gave you another point and it was -7, -5. Q prime is going to be +7, -5, right? So it's opposite. It's not that it's always going to end up as something negative. It might be becoming positive. It just becomes the opposite sign. Reflecting over the line y equals x. This is inverse. xy becomes yx. They switch. This would be -2, -4. This would be 0, -1. This would be right pre-image, image. -3, 1. And if you need to graph it for yourself and see -4, -2. Okay, that was E. -2. 1, 2, 3, 4. That's E prime. If I were to draw that diagonal line, yeah, that looks about right. Look, that's perpendicular. And it bisects. It's not perfect, but it gives you a general picture. The line y equals -x, xy becomes -y, -x. So -2, +4. -3, +1. -2, +1. So I'm switching them. So if I had P is -6, -8, that's P prime would be 8, 6. Switch them and negate them. Let's look at some graphs. So now we're going to actually perform the reflection on a grid. Here you can count, right? Y-axis, here's your y-axis. We did this. L prime, that's not going to change. C prime, notice that I am doing what? I'm labeling as I go. You should be labeling. 1, 2, 3, 4, 1, 2, 3, 4. U prime. And 1, 2, 3, I'm sorry, 1, 2. B prime, and then I'm going to go ahead and connect it. You know what, I'm going to write the coordinate for fun. What happened? My x became opposite and my y stayed the same. What about this one across the x-axis? 1, 2, 1, 2. C prime. 1, 2, 3, 1, 2, 3. H prime, and then, oh, that's going to stay the same. It's x prime. label as you go, because check out, this one looks messy, doesn't it? Because it's overlapping. Oof, that was a bad last line. All right, so XY becomes, my X stayed the same and my Y became opposite. This was my image, this was my pre-image, and this was my image. Okay, the last few, my friends. Write a rule to describe each transformation. So I'm gonna look at all three. So let's check out what's happening to Z, to W, and to S. Ooh, S and W aren't changing. But Z, I went from 0, -4 to 0, 4. So I went from XY to X, -Y. Right? XY to X, -Y. Yeah, that works as though they're zeros. Well, what is this? So there's my rule. There's my coordinate notation, or my function rule, or my function notation. My coordinate rule. There's so many different names for algebraic rule, sometimes it's called. Well, if X stayed the same, that's going to be a reflection over the x-axis, right? Try to challenge yourself and see if you can do it without notes, right? That's our ultimate goal here, is that we understand it enough that we're not like checking each time. Okay, let's see. X became opposite, Y stayed the same. X became opposite, Y stayed the same. X became opposite, Y stayed the same. XY becomes X became opposite, Y stayed the same. Ooh, so that's what? It's a reflection over the y-axis. What about here? X stayed the same, Y became opposite. X the same, Y opposite, X the same, Y opposite. Ooh, it's not like what I just, so XY becomes, X stays the same, Y becomes opposite. So that's, again, a reflect over the x-axis. X became opposite, Y stayed the same. X opposite, Y the same. Fine, right? X became opposite, Y stayed the same. So this one, again, is a reflection over the y-axis. What if I gave you this? And I said, just wanted to do one more. So let's say you got this. So, oh, they switched. I started with X, Y, and they switched. Right? So now I've got YX, but they just switched to, oh no, that became an opposite. And 4, oh, that became opposite. What's this? A reflection over the line Y equals -X. Amazing. So, in this lesson, so at this point, you guys have an understanding of rigid transformations, what they are, translations, and now reflections, right? So the one thing that you haven't done and we haven't spoken about together is the reflections of lines, right? You did the translations of lines. We haven't done the reflections of lines, and that's something that we will talk about and further our understanding, but you might at this point, and that might be a great thing to try on your own, is can you do it right now? Like if you took a line, would you be able to successfully reflect it and write the new equation, right? So use your knowledge from translations. And this is something that, hey, maybe try it now. And if I had, I don't know, this line, the line's defined by 2 points. Could I write the equation of it, reflect it over the x-axis or whatever axis, and then write the new equation? And that's something that we will do, but I would encourage you to investigate it, maybe even before you come to class. You got this, guys. So we learned these rules, right, which were a little different. We talked about how you write the coordinate notation, and we looked at applying that. So as you can imagine, one of the next things that we will be doing is rotations. But first, we will make sure that we have a solid understanding of these. So if you need to go back and review anything, feel free to go go for it, review, and use the resources to practice, and then make sure that you are completing your assignment on before we see you this coming week. So thanks everyone for watching, and reach out if you have any questions. Bye guys.